Okay, so the next thing that we have here is a couple of exercises. So we want to basically, we have basically n combination 19, I'm sorry, n combination 9, n combination 9 is equal to n combination 8. We want to find n combination 17. We want to find n combination 17. So you can see that n, basically 8 and 9, if you add them together, you get a 17. Now you need to somehow use the theorems and everything that we had here in order to find out what we can do with these things. So first of all, basically the things that we talked about here were there were a couple of theorems. There was the formula for combination for combination, which we said that basically n combination. So let me write them down over here, and then we can take a screenshot of all of these things. So we said that n combination r. We said that n combination r is equal to basically n factorial over n minus r factorial times r factorial for basically 0 less than or equal to r less than or equal to n. That was one thing. Then we said that also n combination n is equal to 1 was equal to 1, and also we defined n combination 0 as 1, and also we said that n combination n minus r. We said that n combination n minus r is equal to n combination r. N combination n minus r is equal to n combination r. And also we said that if n combination basically n combination a is equal to n combination b, implies that a is equal to b, or basically n is equal to a plus b. This is also what we talked about. And also we said that n combination r plus n combination r minus 1 is equal to n plus 1 combination r. These are all the things that we talked about recently in the basically combination part. So now what I will do is that I will take save this somewhere on desktop, call it implication on desktop, and then I will make another screenshot over here and call it combination. Combination on desktop. And so now let's go and solve this problem. Okay, so what we have here, basically this method is usually the best thing that I have used, because when the formulas that you have are new and you have recently derived them, you don't know much about them, you haven't worked with them much, then of course it's not a part of your, those formulas is not a part of your active vocabulary of mathematics. Some people call it repertoire. a part of your active vocabulary or repertoire. And so when you're thinking about, when you see a problem, this will not basically these formulas will not come to mind instantly. So it's always helpful to write them down somewhere, at least as long as you're dealing with those kinds of problems, and then you can discard them or you can keep them, or whatever it is that you want to do with them. That would be another matter, but this method actually works very well. For example, when you're dealing with one particular chapter, for example, related to combinations or related to permutations and that sort of thing. And of course, in a typical chapter, you will get, in a typical chapter of, for example, 30 pages or 35 pages or so on and so forth, you will not get more than 5, 6, 7, 8 formulas. So this kind of thing you could typically do in any chapter, really. Now, to solve this problem, what you can do is that you know that basically n combination 9 is equal to n combination 8. So we said that basically if n combination So we said that over here, we said that if n combination A is equal to n combination B, that implies that either A is equal to B, that implies that either A is equal to B, or n is equal to A plus B, right? So of course here, A cannot be equal to B, so I cannot use this condition. But then I can say that n is equal to A plus B. So that means that n is equal to A plus B. So since n is equal to A plus B, then that means that basically in this particular case, n is equal to 17. So now since n is equal to 17, then n combination 17 is the same thing as 17 combination 17, which is equal to 1. Because we said that n combination n is equal to 1. And let me see if that is correct. Yes, that is correct. And the way that they have solved this problem is basically they have written n combination 9. We had n combination 9 is equal to n combination 8. That's the problem that we had. If you simply not use the formula that I just used and write this as basically, you know that n combination r is equal to n factorial n minus r factorial times r factorial, then over here you would get n factorial over n minus 9 factorial times 9 factorial is the same thing as n factorial times over basically n minus 8 factorial times 8 factorial. And so n factorial and n factorial can cancel out here. N minus 9 factorial, you can write it as, so I can write this as 1 over n minus 9 factorial. I can write it as, so this is basically 1 times 2 times 3 times all the way up to n minus 9. And so before n minus 9 is basically you have n minus 8, of course. N minus 8. Because you're over here, you're subtracting a smaller number from n, so n is, no. I'm sorry. Over here, n minus 9 factorial is the same thing as n, all of these, times n minus 9. Now, if I subtract a 1 from n minus 9, if I subtract a 1 from n minus 9, I will get n minus 10. So that means that this term over here would be n minus 10. And this, and by the same logic, this would be n minus 8, right? So that means that n minus 9 factorial, I can write it as 1 times 2 times 3 all the way up to n minus 9, and the term previous to n minus 9 would be n minus 10, which is of course not going to help me much here, because I want to find a way to simplify these two together, n minus 8 factorial and n minus 9 factorial. So what I'm going to do, or even before I do that, what I'm going to do is that I'm going to multiply both sides of this equation by, for example, n minus 8 factorial, 8 factorial. So I will get basically n minus 8 factorial times 8 factorial divided by n minus 9 factorial times 9 factorial is equal to 1, right? And so now I can write this as n minus 8 factorial over n minus 9 factorial times 8 factorial over 9 factorial is equal to 1. Now you can simplify 8 factorial and 9 factorial, meaning that, and before you know this well, meaning that you know that you're not going to make any mistakes, it's a good idea to write them out and see what happens. Otherwise, you might actually make mistakes, okay? So that means that, for example, 8 factorial would be 1 times 2 times 3 through 8. So then the term before it would be 7, and so on and so forth. But 9 factorial, it would be 1, 2, 3 times 1 times 2 times 3 times all the way up to 9. So this would be, so you could write this as, for example, 8 factorial times 9, right? And then you could simplify these two. And now I can multiply both sides of this equation by a 9, and that gives me basically n minus 8 factorial over n minus 9 factorial is equal to 9. Now, to simplify these two, basically if I subtract, so n minus 8 factorial, for example, n minus 8 factorial is the same thing as 1 times 2 times 3 times all the way up to n minus 8. Now, to get the term before this, you have to subtract a 1 from this term, meaning you would get n minus 8 minus 1, which is n minus 9. So that means that over here you can write n minus 9, which is what I'm looking for. So n minus 8 factorial, n minus 8 factorial, I can write it as n minus 9 factorial times n minus 8 times n minus 8. And so that's basically what I want. That's what I will do now. So I will write this as n minus 8 factorial. I will write it as n minus 9 factorial times n minus 8 times n minus 8 divided by n minus 9 factorial, which is equal to 9. And then what I can do is that I can basically simplify these two, and that basically means that n minus 8 is equal to 9, which means that n is equal to 17. And of course you saw that basically using that formula we got this very easily, meaning that we said that if n combination A is equal to n combination B, that implies that either A is equal to B or n is equal to A plus B. And the question that we were trying to solve was n combination 9 is equal to n combination 8, which implies that either 9 is equal to 8, which is not true, or basically n is equal to 9 plus 8, which is equal to 17, which is actually true. So now then what we wanted to calculate was n combination 17, which is the same thing as 17 combination 17, which is equal to, well, n, which is the same thing as n combination n, which is equal to 1. So that's how they have solved this problem, which is of course a good way of solving the problem. Okay, so that is that. Now I think, so now let me stop here for a few moments. Okay, so now what I'm going to do now is that we have basically talked about all of the concept in this, the whole concept that we had in this chapter was 474. So basically that the whole concept that we had in this chapter was permutation and combination. Now we have basically talked about permutation, we have talked about combination, and everything that, concept wise, we have talked about everything in this chapter, which was basically chapter 7 of class 11, permutations and combinations. Now what I need to do now is that I need to basically publish the same course on udemy.com. So you can always go to basically this website here, udemy.com. And of course, if that works, I'm not sure. Let's see. So let me get this website. That'll be right. Now, for whatever reason, it seems that the website is not working right now. I'm not sure what the problem is, or let's see, for example, if this website is working. Yes. There is nothing wrong with my internet connection, but this website is not working. Now, anyway, I will basically there is a what I will do from now on is that I have a website over here called greatitcourses.com, where I used to basically publish my mathematics courses, and back then it was basically a bunch of books from the OpenStax College. So this was basically the books that I used to do. OpenStax.org. So if you go to, for example, subjects math, you can see there is a book over here, Algebra and Trigonometry. I was basically busy with this book. This is basically almost every basic concept in mathematics, of course not including, for example, the very basic things like, for example, addition and subtraction and that kind of thing, and all of the laws related to those things. And those things are probably dealt with in these books. And I was basically, and I had this plan that basically got you from the very basics of mathematics all the way up to calculus. Now, for a couple of reasons, in the middle of when I got to trigonometry here, I stopped this path because of some problems, and then I decided to basically go with the mathematics starting from class 6 all the way up to class 12. And then at the time I wrote this very short, not exactly very short, but I wrote this article over here showing that I was doing the same. Now the thing is, now what I'm going to do here now, I'm going to create a new, basically a roadmap, starting from basically mathematics class 6. I'm going to basically break down all of these chapters into, for example, module 1, module 2, module 3, module 4, all the way up to the last part of class 12, which will be summers, which will be most probably, for example, you have class 6 there, you have class 7, you have class 8, 9, 10, 11, 12, and basically each of these is going to be 16 chapters each. 16 chapters each, which means that you get 7 times 16, which is equal to 70, and 42, so that's something around 112 chapters. So you can 112 chapters. So you can imagine that would be probably something about 112 courses. 112 courses on Udemy. Most of the time, what I'm going to do, of course, the problem is that now I have gotten past basically class 6 I've already recorded on my own, class 7 I have recorded, 8 I have recorded, 9, 10, and I'm kind of in the end of class 11. And I have class 12, class 12 I haven't done yet. So what I will do is that, for example, as you saw over here, basically I had to talk a little bit about permutation and combination, and of course that's the kind of thing that you can do as well, because when you talk about something and when you try to explain something to others, of course you will learn it much better than if you were trying to learn it on your own. So basically whatever I did basically in that phase of the work. I upload everything to YouTube, and you can use that. All of those things you can use free of charge. But then now what I'm going to do is that I'm going to start from the beginning of class 6, and out of each chapter I'm going to create courses. You will have basically something about 112 courses, 112 courses in total on Udemy. You can go over there and let's see if the website is still not working or working. This is udemy.com. And if you go, for example, for great IT courses, you will get to, for example, these are the courses that I used to do before. You see over here, for example, algebra, trigonometry, and these are all of the courses that I have already done. So basically these are all the courses that I have already done over there. So I have done these mathematics courses. Some of them are even free, some of them are not free. There is even one course over here related to HTML and CSS and that sort of thing, which is not the kind of thing that I might do anymore in the future. But then all of those courses you are going to find on Udemy here. On this you can basically bookmark this address, https://www.udemy.com user great IT courses. This exact address, you can get to this page, and whenever there is a new course you will have access to that here. And additionally, whatever I'm doing basically in mathematics, whatever I'm doing on my own which is not related to those courses, I will put them on YouTube free of charge, and of course you can use them free of charge. So that means that if you basically need more practice or more material related to this chapter 7 of class 11, which was permutation and combination, then probably in a few days time, and today is October the 2nd, 2019. In a few days time, I'm going to basically create this whole course for Udemy from the very beginning to the very end. I'm not sure what exactly I'm going to include in there, but I'm going to include enough in order for the whole concept to be understood properly. And then you will have access to that course there. And basically there is still class 12 that I haven't gone through myself yet. So that's going to be at least some parts of that. Exactly like this part of this course is going to be on YouTube as well. And of course, basically these parts over here are going to be, I'm going to create courses from these as well. And if I happen to have something which is worth your while, I'm going to put that on YouTube as well. And that's basically what I will do from now on. Excuse me. So that's basically the whole story here. So now I thank you for your attention, and in case you want to know more about, and there is one thing that's also I'm going to put on YouTube as well from now on, and that is basically the exercises related to all of these chapters that you can find in all of these books, because I'm not going to include basically the exercises in the courses on Udemy. I'm going to just do them on my own, put them on YouTube, so that if there is a student who has a problem with any of those courses, then they can come to YouTube and basically take a look at the solutions on YouTube. Because as a student, you're supposed to do the exercises on your own, otherwise you wouldn't understand the concept properly. But of course, I'm providing the solutions free of charge on on YouTube. So that's basically what I'm planning to do. And so if you are in need of basically mathematics from the very basics, the very basics of mathematics, starting from addition and subtraction, that sort of thing, going all the way up to class 12 over here, calculus, using this system of basically Indian basically system of mathematics, which is in my humble opinion the best system I've ever used I've ever seen in my whole, in everything I've seen about mathematics, and I've seen probably enough about mathematics. I suppose it's actually the best way to learn mathematics, and you know that Indians are actually famous for mathematics, and that there must be a reason for that, and the reason must be that they do a lot of mathematics, really. So you can see that these books are not, I mean, it's not that easy to deal with these books. And there is a whole lot of pages, there is a whole lot of material in there, but well, at the end of the day, if you do them properly, you will learn mathematics properly. So that's how it is. So that's the whole story. Now I'm going to head back to basically Udemy and start basically creating my course, the courses over there. And of course, there will be a whole lot that I will still be uploading to YouTube as well. So I thank you for your attention, and I'll see you in the next videos. Thank you.